After years of silence and speculation, Airbus has made a move no one saw coming, and it's rattling the foundations of the aviation world. Forget what you think you know about wide-body jets. The rumored arrival of the Airbus A390 isn't just a product launch, it's a potential direct answer to the industry's most pressing challenges. With whispers of tech pulled straight from experimental labs, and a rumored performance leap that could sideline even Boeing's most ambitious plans, this aircraft may not just fill a gap, it might change the rules altogether. One detail in particular is already raising eyebrows in executive boardrooms and control towers alike. What exactly did Airbus build into this jet that's catching legacy carriers and competitors off guard? Stay with us, because this isn't just about a new plane, it's about a strategic pivot that could redefine the future of long-haul travel. The strategic gap left by the A380's demise. The retirement of the Airbus A380 in 2021 marked a turning point in the commercial aviation industry, especially for high-capacity, long-haul routes. Originally envisioned as a flagship solution for densely populated intercontinental travel, the A380 struggled to meet evolving airline and market demands. Its design prioritized volume over flexibility, which limited its practicality. Only 140-150 airports globally could handle the aircraft's size, and its dependence on hub-to-hub operations became a liability as the industry shifted toward point-to-point models. As a result, Airbus found itself with no direct replacement for the segment the A380 once targeted. This strategic gap has left airlines with fewer options when it comes to transporting large numbers of passengers efficiently across long distances. While many carriers have downsized to more fuel-efficient, smaller wide-bodies, certain routes, especially those constrained by airport slots, still benefit from higher-capacity aircraft. The absence of a modern, large-capacity airliner that fits within existing infrastructure has created a vacuum. Airlines like Emirates, which built part of their business model around the A380, have emphasized the ongoing need for such aircraft, particularly in markets where passenger demand continues to grow and slot availability remains limited. The failure of the A380 was a result not of a technology gap, but of owed alignment with the market dynamics. The move away from centralized hub-based travel to point-to-point, the aircraft was largely rendered less useful for most carriers given its configuration of 4 engines, as in an era where great twin-engine wide-bodies give a comparable range at much lower operational costs. Airlines find it increasingly difficult to fill the A380 to the brim profitably, especially on those routes that do not always require that scale. The underutilization, coupled with higher per-passenger costs, undermines the long-term economic viability of the aircraft. Airbus faces both a challenge and a reward in the sudden disappearance of the A380, with no immediate replacement to fill the gap. Developing an aircraft that could keep part of the capacity benefits of the A380, although perhaps not under those operational limitations, size, efficiency, and airport access, would target a market area currently underserved. The A390, rumored for some time, could be Airbus's answer not as a direct continuation of the A380 legacy, but a reimagined solution to today's airline economics and travel needs. As airlines search for the next true workhorse of high-capacity travel, one familiar aircraft surprisingly falls short of the mark. Why the A350 isn't enough. The Airbus A350 has become the cornerstone of Airbus's wide-body strategy since the phase-out of the A380, but it was never designed to fully fill the strategic gap left by its larger predecessor. Positioned as a long-haul, fuel-efficient twinjet, the A350 targets both medium and long-range routes with high performance and relatively lower operating costs. While the A350-1000 variant pushes toward the upper end of passenger capacity, seating up to 410 in a typical configuration, it still falls short of replacing the true high-capacity capabilities that defined the A380's role in certain markets. In contrast, Boeing has adopted a two-pronged approach in this segment with its 787 Dreamliner and the upcoming 777X. The 787 series offers flexibility for long-haul routes with varying passenger loads, while the 737X is positioned as a high-capacity alternative capable of carrying up to 426 passengers. This diversified strategy allows Boeing to serve a broader range of airline requirements, from point-to-point operations to dense international hubs. Airbus's current reliance on a single wide-body platform puts it at a competitive disadvantage, especially in scenarios where greater capacity or operational redundancy is critical. The A350 further constrains its limited reach into almost every dimension of airline application needs by scaling. This aircraft is efficient with technology efficiencies and well-liked by airlines, but redesigning spends a lot of effort to extend the platform to compete at the very top end with the 777X for capacity and payload. There is no variant in the A350 lineup at the moment capable of providing a vast change in capacity, which airlines like Emirates or Air India might eventually be considering as essential, particularly for slot-constrained airports, requiring maximized revenue generated per flight. With these facts, new aircraft thinking, especially on the supposedly A390, transcends a mere hypothesis. It may even require Airbus so that it can remain relevant in the high-end wide-body market. Sure, the A350 is good, but no matter how good, it can never hold up against Boeing's double aircraft advantage forever. A fresh new platform will solve Airbus's strategic re-entry into high capacity, with a design more congruent with today's operations, environmental objectives, and fleet optimization strategies. Even more critically, the A350's current architecture limits its ability to be stretched or adapted without running into diminishing returns on performance. Increasing capacity further would likely compromise range, fuel efficiency, or cargo space, three non-negotiables for modern long-haul operations. Airlines looking for a next-gen solution that combines scale with economics are beginning to see the ceiling on what the A350 can realistically deliver. In that sense, pushing the A350 to do more than it was designed for risks, creating the same kind of platform fatigue that Boeing experienced with older 747 variants toward the end of their life cycles. This growing pressure is what makes the concept of the A390 more than just another new jet. It signals a pivot away from incremental upgrades toward a clean-sheet aircraft built for scale, sustainability, and future demand. If Airbus can deliver an airframe that not only exceeds the A350's limits, but does so without inheriting the A380's baggage, it will have a strategic upper hand. The A390 isn't meant to replace the A350. It's meant to liberate Airbus from relying on a single wide-body solution in an increasingly complex market. Debunking the triple-decker. When speculation around the Airbus A390 began circulating, one of the more persistent and eye-catching rumors was the concept of a triple-deck aircraft. Viral mock-ups, many of which originated as April Fool's jokes or fan creations, depicted an enormous airliner with 3 passenger decks, a clear exaggeration of what might realistically be viable in commercial aviation. While the idea sparked curiosity, it quickly drew criticism from aviation experts, who dismissed the feasibility of such a design. The reality is that a triple-deck aircraft would pose significant engineering, operational, and regulatory challenges, many of which mirror the very issues that plagued the A380. The A380 already highlighted the limitations of oversized aircraft, airport compatibility, weight restrictions, and inefficient fuel consumption due to its size and 4-engine configuration. Expanding to a third deck would only amplify these challenges. More structure means more weight, which demands more powerful, and potentially more, engines, increasing both fuel burn and maintenance costs. Additionally, such a design would likely limit the aircraft to an even smaller number of airports than the A380, severely restricting its commercial viability. For Airbus, repeating this kind of design miscalculation would contradict the direction in which the industry is clearly moving, toward greater efficiency, not sheer scale. That is precisely where recent indications actually suggest that Airbus learned from the A380's commercial failures. By no means credible are the claims that the A390 is intended to be a resurrection of the concept of the super jumbo. All indications point instead to a more cautious, single-deck, as wide as a double-deck body, that would meet the market demands. Striking this balance implies a more general understanding of the industry that new airplanes could be more capable, efficient, and flexible operationally, rather than introducing to the world the biggest jet. The A390 is thus envisioned not as a spectacle, but as a practical solution for future airline needs. In direct opposition to the triple-decker rumor, Airbus is showing how serious the fate of the company and its products could become if the past popular view of creating possessions that consumers cannot buy were revived. Also reaffirming the engineering discipline with its attention to the world's marketplace is Airbus itself. The A390, if pursued, is not likely to be a futuristic showpiece, but rather earns its keep and earns it well. In not pursuing grand, but commercially risky designs, Airbus has tied its next wide-body aircraft to the realities of the industry: fuel efficiency, range, flexibility, and cost control overhead. It's no longer about pushing physical boundaries, rather it's delivering sustainable, scalable innovations. What many of these triple-deck concepts fail to acknowledge is the logistical complexity such an aircraft would introduce into daily operations. Boarding and deplaning times would dramatically increase, emergency evacuation procedures would become more difficult to certify, and cabin crew ratios would need to be significantly expanded. Even if the engineering were theoretically feasible, the practical day-to-day realities for airlines, turnaround times, catering logistics, baggage handling, would be stretched beyond current limits. These factors make the triple-decker idea not just improbable, but operationally unsustainable in a world where speed and efficiency drive profitability. Moreover, pursuing such an extreme configuration would run counter to the direction both regulators and airlines are moving, toward simplification, not complexity. Airbus appears to understand that the future of long-haul aviation lies in intelligent design, not oversized spectacle. The A390 is being shaped by lessons learned from past excesses. Instead of doubling down on scale for the sake of novelty, Airbus is prioritizing performance that fits within existing airport ecosystems. That's not just good engineering, it's smart business strategy. A390's projected capacity and range. Airbus appears to be positioning the A390 as a next-generation wide-body aircraft capable of redefining what high-capacity, long-range jets can achieve. Early indications suggest the aircraft will feature a seating capacity in the range of 450 to 470 passengers, depending on configuration. This would place it above the A350-1000 and even Boeing's upcoming 777X in terms of pure capacity, making it one of the largest twin-engine passenger aircraft in development. Such figures suggest that Airbus is aiming to bridge the gap between the now-retired A380 and its current lineup, while maintaining operational flexibility. Beyond capacity, range is another area where the A390 could set a new benchmark. Reports suggest that the aircraft may offer a maximum range of around 11,500 miles, significantly more than the larger 777X variant, which tops out at approximately 10,046 miles. This extended range would allow airlines to operate non-stop flights on ultra-long-haul routes such as Sydney to New York or London to Santiago without compromising payload. In an industry increasingly driven by the ability to link far-flung cities directly, this capability could become a major selling point. Compared directly with Boeing's products, the A390 specification can surely tilt the balance in Airbus's favor. The 777-9, being the higher capacity variant from Boeing, can seat up to 426 passengers and has commendable range, but does not seem to match the rumored numbers offered by the A390, either in range or capacity. The 787 Dreamliner, on the one hand, qualifies for flexibility and fuel economy, but has a narrow pass-by volume and short-range considerations, typically targeting smaller capacities and a lesser range vis-à-vis what the A390 may be able to deliver. The A390 could generate airlines' interest in consolidating and enhancing slot-limited airport operations artillery if successful in balancing range, capacity, and efficiency. The A390 must retain compatibility with major international airports' infrastructure, avoiding the limitations that have rendered the A380 practically unusable from some airports. This balance between high capacity and accessibility could confer versatility across airline networks for the A390. Instead of needing specially rigged terminals, the airplane might work alongside other wide-body jets with no further expenditure by airport operators issue, which will be critical to airline route planning and turnaround efficiency. If Airbus achieves these aims, the A390 could forge an entirely new path in long-haul, high-capacity aviation. Advanced materials and structural innovation. One of the key differentiators for the Airbus A390 could be its expected use of advanced composite materials, particularly carbon fiber reinforced plastics, CFRP. These materials have become increasingly important in modern aircraft design due to their strength-to-weight ratio and durability. Airbus has already seen success with this approach on the A350, which incorporates about 53% composites by weight, slightly more than Boeing's 787 Dreamliner. For the A390, Airbus is likely to go even further, potentially using an even higher percentage of composites to reduce structural weight and improve overall fuel efficiency. Using more composite materials offers several tangible benefits. First, the weight savings directly translate to lower fuel consumption per passenger, which is especially critical on long-haul routes where operational costs are magnified. Second, composites are more resistant to corrosion and fatigue compared to traditional aluminum, which can significantly reduce maintenance demands and increase the aircraft's service life. These qualities not only improve airline profitability, but also enhance environmental sustainability, an increasingly important factor in aircraft procurement decisions. Further, arriving at the end of the fuselage and airframe, next-generation composite material also surrounds the wings of the A390 under consideration by Airbus. It had been involved with the production of a novel wing design which would enable flexibility within morphing surfaces, integrated wings, where lighter, stiffer materials support the emerging dynamic control features being explored. CFRP's flexibility in variation of shape strength has allowed Airbus to draft relatively more aerodynamically efficient surfaces for drag and improve lift-over-drag ratios. Thus, it could add further savings in fuel on ultra-long-haul missions where fractional increment improvements accrue miles after thousands. If Airbus can do this at all, then it is taking a rather huge step in structural efficiency, if not cost-effective performance, for the A390. Toward that end, the use of composite-intensive designs would only add to what increasingly more companies consider an industry move in that general direction. Airbus's edge, however, is that it can now reap the most benefit from its experience and refinement of these technologies through many different proprietary programs. For that matter, airlines and a long-lasting airframe could give the A390 factored differences in asset investment, particularly at the longer ranges that flowed out of these efficiencies. While lighter materials lay the foundation, it's what Airbus plans to do with the wings that could truly redefine flight. Revolutionary wing technology. One of the most anticipated innovations in the Airbus A390 program is its potential integration of adaptive wing technology, a development aimed at real-time aerodynamic optimization. Airbus has been actively researching a new generation of wings capable of adjusting their shape during flight, using active control surfaces and morphing structures. These dynamic adjustments would enable the aircraft to respond more effectively to changing flight conditions, such as turbulence or crosswinds, improving efficiency and stability throughout various phases of flight. Key to this innovation is the inclusion of advanced gust sensors on the leading edges of the wings. These sensors would continuously monitor airflow and detect sudden changes in wind patterns or turbulence. When paired with smart control systems, the data collected would trigger immediate adjustments to the wing's flaps, slats, or other control surfaces. The result is a smoother ride for passengers and optimized lift-to-drag ratios for the aircraft, both of which contribute to reduced fuel consumption and lower emissions. The advantages of such a versatile wing system are considerable. With wings optimally shaped in real time, The A390 could, therefore, cut drag remarkably more than fixed-wing designs at cruising altitude and during long-haul flights. This results in substantial fuel savings, which is garnering increasing importance in airlines' competitive environment of cutting costs and carbon emissions. On the other hand, better turbulence mitigation may also translate into reduced structural fatigue over time, effectively increasing the lifespan of the aircraft and reducing maintenance costs. If the A390 is to be the first Airbus aircraft to bear the adaptive wing design, it will constitute a landmark in the advancement of commercial aviation technology. This concept has been tested in demonstrators. Taking it through into a full production aircraft shows that Airbus intends to go ahead with the commercialization of next-gen aerodynamics. The attraction for the airlines is evident in aircraft that smartly adjust to flying conditions and lower operation costs while complementing environment-friendly objectives. For Airbus, it could create a new benchmark in wing performance that would provide a competitive advantage against Boeing's products. Rolls-Royce Ultrafan and beyond. A major propulsion innovation under consideration for the Airbus A390 is the integration of the Rolls-Royce Ultrafan engine, a next-generation turbofan that could offer up to 25% better fuel efficiency compared to current engines in service. The Ultrafan has been in development for over a decade and incorporates several new technologies, including a geared turbofan design and advanced composite fan blades. If selected for the A390, this engine could significantly lower fuel burn per seat, making the aircraft more competitive on long-haul routes while helping airlines reduce operating costs and carbon emissions. The Ultrafan is also designed with scalability in mind, meaning it could potentially be adjusted to match the specific thrust requirements of the A390. Its modular architecture allows for flexibility across different aircraft sizes and mission profiles. For a large widebody like the A390, expected to carry over 450 passengers and fly ultra-long-haul distances, having an efficient and adaptable power plant is essential. The improved bypass ratio and lower specific fuel consumption of the Ultrafan could enhance the aircraft's economic performance without compromising range or payload. This means that beyond the Ultrafan, Airbus will turn to developing even more radical propulsion technologies as part of its Zero program, which focuses on hydrogen solutions for real zero-emission flight. Definitely, it will take time before a hydrogen-powered A390 gets into the air. Nevertheless, according to the head of Commercial Aircraft Research and Development, nothing precludes the possibility that hydrogen might, at some point in the future, be available as one of the more radical forms of propulsion for a large commercial airliner. This program includes, among others, designs ranging from hydrogen combustion engines to hydrogen fuel cell-powered electric motors, just two technologies that can influence future iterations or successors of the A390, be it hybrid or hydrogen-based. If Airbus integrates such propulsion into its wide-body line, it is establishing the basis for the A390 concept, which would enable some early experience with incorporating future technologies within a broader platform, given the possible configurations of adding partial hydrogen electric systems or hybrid auxiliary power units. Although currently not scheduled for introduction with the first aircraft, the ability to retrofit green propulsion in the future will likely result in a longer commercial lifespan for the A390 and superior future alignment with worldwide decarbonization targets, whether using Ultrafan efficiency or hydrogen propulsion. In the future, the commitment of Airbus in making this A390 an aircraft of the future and fuel-efficient is clearly articulated. Meeting growing global demand. One of the clearest signals that the commercial aviation industry is evolving comes from the sustained growth in global air travel demand. According to recent data from the International Air Transport Association, IATA, international passenger traffic has nearly returned to pre-pandemic levels, and future projections estimate long-term growth of over 4% annually for the next 2 decades. Much of this growth is being driven by expanding middle-class populations in countries like India, China, and throughout Southeast Asia. regions where air travel is becoming more accessible. This surge in demand requires aircraft that can transport large numbers of passengers efficiently and economically. At the same time, airport capacity is not growing fast enough to keep up. Major international hubs like London Heathrow, New York JFK, and Tokyo Haneda operate near or at full slot capacity, making it difficult for airlines to add more frequencies. In these environments, airlines must focus on maximizing the number of passengers per flight rather than increasing flight numbers. A high-capacity aircraft like the Airbus A390, which is expected to seat 14,470 passengers, could provide a crucial solution. By carrying more passengers in a single takeoff and landing, the A390 would help airlines optimize scarce airport slots. This is not just a typical challenge that would affect a single legacy carrier. Emerging national airlines in rapidly developing economies have flagged this issue as a concern in the ongoing challenge to find long-term solutions to expand long-haul fleets. The A380 retired, the A350 is lacking in terms of capacity, and the truly unique opportunity that the A390 could provide airlines will be to assist with addressing a larger portion of growing international demand without new airport infrastructure. Furthermore, its projected fuel efficiency and capability to utilize existing wide-body airport infrastructure give it a major strategic advantage in high-demand markets that are both physically and regulatory constrained. The A390 would not only allow escalating flight volumes to be accommodated in terms of airport capacity demand, but could also add to per-flight efficiency, very much in the industry's move from more volume to greater efficiency per flight. Such an approach is expected to reduce the ever-pressing demands on already congested airports while reducing emissions per passenger, an increasing concern as both regulators and traveling publics today demand greater sustainable operations. Given the high capacity, long-range capabilities, and operating efficiency of the A390, it is expected that an airline would favor this option when demand surges and airport resources dwindle. Acquisition and operational efficiency. From a financial perspective, the Airbus A390 is expected to come with a list price in the range of $400 million, based on projections that position it just above the A350 $1,000, $366.5 million, and slightly below Boeing's 700 Saturn X, which is officially priced at $442.2 million. While most airlines negotiate significant discounts from the list price, this estimated figure gives a reference point for how Airbus may position the A390 within the wide-body market. The combination of greater capacity, extended range, and next-generation efficiency features could help justify the premium compared to the A350, while still undercutting Boeing's flagship competitor. Operational efficiency will be a key part of the A390's economic appeal. With its projected use of the Rolls-Royce Ultrafan engine and advanced lightweight materials, the A390 is expected to offer substantial reductions in fuel burn and maintenance requirements. These savings translate into lower cost per available seat mile, a CASM, which is a critical metric for airline profitability. For carriers operating long-haul, high-density routes, a 25% improvement in fuel efficiency, as targeted by Ultrafan, could equate to millions in annual savings, making the A390 an attractive financial proposition over its life cycle. There is yet another potential advantage of the A390 that Airbus could offer, which is reducing pilot training. If pilot training and flight systems are set to be common with the A350, that can reduce transition time for A390 pilots. It worked well for the A320neo family, where airlines saw a reduction in training costs and an increase in the flexibility of the crews. In the case of the A390, sharing systems with the A350 means that operators can rotate crews with minimum retraining, thus lowering the barriers for existing Airbus customers and enhancing the aircraft's attractiveness to large-scale global fleets already operating Airbus widebodies. Maintenance and service economics are, however, presumed to favor the A390. Due to its composite materials and modular systems already applied in the A350, it can be said that Airbus will offer less of an aircraft in terms of downtime long maintenance intervals, and infrequent parts replacement. Interestingly, if the A390 starts up with digital maintenance and performance monitoring tools as a standard package, prediction analytics will assist airlines in optimizing the usage of their components in a performance-based maintenance contract by alleviating unplanned repair schedules. The combination of an attractive value proposition for acquisition and operating savings makes the A390 a worthwhile asset for a competitive total cost of ownership. As Airbus sharpens its edge on efficiency and economics, its biggest rival is grappling with deeper issues that go far beyond just delays. Boeing's vulnerability and inability to respond. Boeing currently faces significant headwinds that could impair its ability to respond effectively to the launch of the Airbus A390. Chief among these is the repeated delay of the 777X program, which was originally scheduled to enter service in 2020, but is now not expected before 2025 at the earliest. This delay has eroded confidence among key airline customers and left Boeing without a viable high-capacity, long-haul twinjet in the near term. Meanwhile, Airbus appears to be accelerating development of the A390, a potential competitor with greater capacity and range, which could arrive just as the 777X finally reaches market, undercutting its momentum. In addition to the 777X delay, Boeing is still entangled in regulatory challenges tied to the 737 MAX 7 and MAX 10 certifications. These variants remain uncertified in mid-2025, limiting Boeing's ability to refresh its narrow-body lineup and diverting engineering resources and leadership attention away from wide-body innovation. The FAA has maintained close scrutiny over Boeing's quality control and documentation processes following the 737 MAX crisis, further slowing progress on new product initiatives. In contrast, Airbus continues to benefit from regulatory stability and smoother certification pathways, particularly with the A350 family already certified and in widespread service. Internal cultural and leadership issues have, in part, figured in Boeing's slow response. Observed and presented by industry commentators and whistleblowers over time, a schism between management and engineering teams has generated an endless cycle of manufacturing calamities, from fuselage defects on the 787 to program-wide production halts. These internal challenges have impaired not just product quality, but also customer relationships due to complications engendered. On the other hand, Airbus seems to persist as a more united force in terms of direction of development. The open skies for the A390 may hence be visible evidence of that organizational stability and long-range strategic planning. If delivered as envisaged, the A390 may bring in high capacity, long-range capability, fuel efficiency, and compatibility with airport standards, but this will also be a defining point in the A390 conflict for the two aerospace giants against each other. The A390 can very well put a chink into the plans for Boeing's wide-body aircraft and further push the market into Airbus's hands, more especially for long-haul operators looking to update their fleets. Hence, the A390 is not just a new aircraft. It could also be the signal of an expanding performance and innovation chasm that leaves Boeing scrambling to catch up in its most profitable segment. If you found this breakdown of the Airbus A390 eye-opening, make sure to like the video, drop a comment with your thoughts, and subscribe for more deep dives into the future of aviation. And don't go anywhere. Click on the next video on your screen to see what Boeing's next move might be.